All right, so we are going to use implicit differentiation to find dy dx to find y prime. Step 1 is to take the derivative of both sides with respect to x. Derivative of the left-hand side is equal to the derivative of the right-hand side. Okay, now to take these derivatives, you want to look at how those functions are put together. I see a function of x minus another function of x, all squared. My inside function is right here. My outside function is squaring. So using chain rule, we get 2 to the power of 1 evaluated at my inside function. Chain rule times the derivative of that inside function. The derivative of x is 1 minus the derivative of y is 1 times a y prime. It's just y prime. Now this one we want to slow down and look at the operation between x and y. That's multiplication right there. I'm going to need product rule. My first function is x first times the derivative of second. My second function is y. The derivative of y is y prime, plus my second function y times the derivative of first. The derivative of x is 1. And then minus the derivative of 1 is just minus a 0. Right, so this part right here is real important to see that product. Here we've used product rule right there. Okay, I'm going to just drop my color and keep the y primes being pink because in our next step we are going to want to solve for the pink. So I'm not doing any math here, I'm just rewriting it and having my y primes nice and visible. Y times 1 is y, minus 0 is just y. Okay, so step 2, we're going to want to solve for y prime. All right. So I'm going to go ahead and distribute that 2. 2 times x is 2x, 2 times minus y is minus 2y, and then that's being multiplied by a 1 minus y prime is equal to the right-hand side. I'm not doing anything with that. All right. And to solve for y prime, I need to get all of those y primes on one side of the equation. This one is tied up in this multiplication, so first I have to go ahead and use my distributive property, and then I will be able to get all of my terms that have y prime in them on one side of the equation. 2x times 1 is 2x. 2x times a minus y prime is minus 2x y prime. Minus 2y times 1 is minus 2y, and minus 2y times a minus y prime is plus 2y y prime is equal to the right-hand side. All right. So now I need to get all the y primes on one side of the equation. I am happy with this guy being here and this guy being here, but let's go ahead and subtract x y prime from both sides. Minus x y prime minus x y prime. Notice that we have some like terms when we do that. Minus 2xy primes minus another xy prime will be minus 3xy primes. So we got 2x minus 3xy primes minus 2y plus 2y prime is equal to x minus y prime, sorry, xy prime minus xy prime is 0. We did that on purpose. Plus y is just y. Excellent. So now I see all these terms, the 2x, the positive 2x right there, and the minus 2y right there, they don't have y prime factors in them. So I'm going to get those guys on the right-hand side of the equation. I'm going to go ahead and subtract 2x from both sides, and I'm going to add 2y to both sides. When these equations are long, sometimes it's real helpful to kind of keep track of your equals sign. Makes it a little easier to read. All right, so we got 2x minus 2x is no x. We've got minus 3x y prime. Minus 2y plus 2y is plus nothing. Plus 2y y prime is equal to y plus 2y is 3y, and then minus 2x is 3y minus 2x, and I'm almost done. What I have to do now is I have to go ahead and factor out that y prime on the left-hand side of the equation. Y prime times a minus 3x plus 2y. Beautiful. Y prime times a minus 3x is y prime times a minus 3x, and y prime times a positive 2y is positive 2y prime. So now I'm ready. The thing that I'm looking for is being multiplied by just one thing. I'm going to go ahead and divide both sides by minus 3x plus 2y, and I am done. And as always, I write a little big, so let's fit it on there, and we're done. Y prime, the function that tells me the slope of the tangent line at any point x comma y on this curve, is given by this function, this rule. Y prime is equal to 3y minus 2x, all divided by minus 3x plus 2y. Done. Beautiful.